Alright, today we're going to look at the quotient rule. So the quotient rule is if we have one function being divided by another function. For example, f divided by g, where f and g are two different functions. So the quotient rule is similar to the product rule, but has a extra little bit to it. So if you remember, the product rule was f dash g plus f g dash. Main difference is that the quotient rule has a minus here, but it also has a divided by g squared. It is very important that we have these two round the right way. So you notice that f is on the top, g is on the bottom. It is very important that you differentiate the f, times it by the g, and then subtract differentiating the g and timesing it by the f. So that's a common mistake that people do make. They'll do that one minus the other one. You'll get it wrong. So let's do 3 examples. First one, let's just get straight into it. The top function is going to be my f. So in this case, f equals to x cubed, and g is equal to 2x minus 1. So I need to find an expression for f dash and g dash and then put it all into my formula. So f dash, differentiating x to the power of 3. This is just our level 2 stuff. We bring the power down and subtract 1, so 3x squared. G, again, it's the same type of thing. So 2x becomes 2. Negative 1 differentiates to become nothing, or 0. So these are my 4 pieces, and now I just have to put them into the formula to find the derivative of this quotient, x cubed divided by 2x minus 3. Again, it is tempting to just differentiate top, differentiate bottom, and be done. That is not how it works. So y dash, my derivative, is going to be f dash g, 3x squared times by 2x minus 1. Put that in a bracket because it's more than one thing. Subtract f g dash. So f was x cubed, g dash was just 2. So I can just put that at the front. Divide it by g squared. So that's 2x minus 1 squared. Final answer. Obviously, there could be some simplifying if we really wanted to. Let's see where this will go. Multiply that out, I'm going to get 6x cubed minus 3x squared minus 2x cubed. Leave the bottom how it is at the moment. And we've got 2 x cubed things, so that can subtract and become 4x cubed minus 3x squared over 2x minus 1 squared. I'm just going to leave it like that. This would give you the correct answer, and it's only an achievement question. Second one, getting a tiny bit trickier here. We're going to look at some of our other types of functions. I've just got our formula sheet here to help us. So again, I'm just going to write my f, my g, my f dash, and my g dash. So f in this case is 2 tan of 5x. G is my e to the 1 minus x. So f dash, now we have to be a tiny bit careful here. F dash, differentiating this. Remember, the two, any numbers multiplied at the front, we say they tag along for the right, or they just multiply to whatever we get. Differentiating tan of 5x, I come over here, tan of x differentiates to 6 squared of x. But there's a 5x here, so I also have to multiply by differentiating that, which is going to be 5. So tan goes to 6 squared, the 2 tags along for right, and there's going to be a 5 multiplied as well. So I'll write 2 6 squared of 5x times by 5, which could be written as 10 6 squared 5x. The 5 multiplied at the end, the 2 multiplied at the front can multiply together. Important in this case, this 5x can't multiply to these 2's or the 5's, because this 5x is bound by the 6 squared. So this is kind of like a package. You can't remove that 5x outside of this thing. The 5x must stay with the 6 squared. So that's my differential of 2 tan 5x. Again, this one we have to be a little bit careful as well. Common mistakes having with this. So e E differentiates to become to itself, but if it's more than just E, we have to differentiate that, and this is where people make a mistake. Differentiating 1 minus x. Remember there's like a 1 here. 1 goes away. Negative 1x would differentiate to be negative 1, so it's going to become negative 1e to the 1 minus x, or just negative e to the 1 minus x. Okay. Put it all into our formula. So f dash of x, I don't know, can't quite see the formula still. I'll pull this down a little bit. Alright, so we have f dash g, 10 sec squared of 5x times by g, which was e to the 1 minus x, minus, kind of come down on an angle here, minus f g dash, so f was 2 tan 5x times by g dash, which was negative, or times by negative e to the 1 minus x. You have to be careful that I put that multiply here. If I just wrote it next to each other, people could get confused and think it's 2 tan 5x minus that, but I want it to be multiplied by that minus there. So that is my f g dash, and divide it by g squared. So that's the best way to do that is just to put a bracket around whatever g is and square it. This could, because it's negative 2 tan times by negative, you could actually change that to be positive 2 tan, but I'm just going to leave my answer like that to save us a little bit of time. So that's my final answer. Again, this is only an achievement question. You're given the formula. All of these are pretty straightforward skills. You just have to put them together. As long as you've been keeping up to date with these chain rule types of questions and how to differentiate all of our different functions. Let's do one more example. I'll write my formula up here. F dash g minus f g dash divided by g squared. That's our product rule. So for this question, we have f equals to sine of x over 2. G equals to 3x squared minus x cubed. So, some work for us to do here. This one here, it is still achieved, but it's a hard achieved. There's a bit going on here. So differentiating sine goes straight to cos. Because there's more than just x there, I have to differentiate that. Remember, x over 2 is kind of like x over 2 is or actually the same as a half x. So sometimes it's easier to think about it like that, because if we have 5x, 10x, it becomes just 5 or 10, so this just becomes half. So differentiating this, we're going to get cos of x over 2 times by that differentiated, which was a half. So a half cos x over 2. Now this G one is the first thing we learned about the chain rule. We have to do this outer function, so the 3 that squared and then times by that differentiated, or that differentiated times by the outer one. So I'll write it like this: 3 bracket 3x squared minus x to the 2. That's me differentiating this power of 3. 3 goes to the front, that to the power of 2. Then I have to multiply by differentiating the inside of this bracket, which is going to become 6x minus 1. So now that I have my f dash and g dash, put it into the formula and we're done. So this was y, sorry. So now we have y dash is equal to f dash g, a half cos of x over 2 times by g, which was 3x squared minus x cubed. Take away f times by g dash, which was a big long thing, 3x squared minus x to the power of 2 times by 6x minus 1. Divide all of that by this thing here squared. Now, you are allowed to write it like this. You will not get marked wrong for doing this. But just note that if you have a power all to the power of something else, you can multiply them. So you could write the bottom as 3x squared minus x to the power of 6. Alright, so that is our quotient rule. Best way to get this into your head is to practice doing the examples. And good. See you guys.